The Earth is hurtling through space, spinning on its axis at a mind-blowing speed, over 1,000 miles per hour at the equator. So, why the heck don't we feel it? No whooshing winds, no constant dizziness, nothing. It's like we're standing still on a giant cosmic merry-go-round. Today, we're going to unpack this mystery step by step, from ancient myths to cutting-edge science, and even peek into what the future might hold. Buckle up. This is going to blow your mind. Picture this. Thousands of years ago, our ancestors looked up at the stars and figured the whole universe was revolving around us. The ancient Greeks, like Aristotle back in the 4th century BC, were convinced the Earth was the immovable center of everything, a solid, stationary rock with the heavens spinning overhead. It made sense based on what they could see. The sun rising in the east, setting in the west, stars wheeling across the night sky. But cracks started showing in that idea early on. A guy named Heraclides of Pontus, around 350 BC, floated the radical notion that maybe the Earth was rotating on its axis, explaining the daily motion of the stars without everything else having to circle us. Then, in the 3rd century BC, Aristarchus of Samos took it further. He proposed a heliocentric model where the Earth not only rotated but orbited the sun. Crazy, right? But these ideas got buried under the weight of Ptolemy's geocentric system, which dominated for over a millennium with its complex epicycles to explain planetary movements. It wasn't until the Renaissance that things heated up again. Nicholas Copernicus in 1543 revived the heliocentric view in his book on the revolutions of the heavenly spheres, arguing that a rotating Earth simplified everything. Galileo Galilei backed him up in the early 1600s with telescope observations of Jupiter's moons and Venus's phases, showing the universe wasn't Earth-centered. But proving the rotation took even longer, and it sparked heated debates, even landing Galileo in hot water with the church. Humans didn't just sit around pondering this. They got hands-on. Fast forward to the 19th century, when French physicist Léon Foucault nailed it with one of the coolest experiments ever. In 1851, he hung a 67-meter-long pendulum from the dome of the Pantheon in Paris, a heavy brass bob on a wire swinging freely. If the Earth were still, the pendulum should keep swinging in the same plane forever. But instead, it slowly rotated, about 11 degrees per hour in Paris, completing a full circle every 32 hours or so. The Earth was turning underneath it. This was the first direct proof that didn't rely on stars or planets. Foucault's pendulum became a sensation, replicated worldwide, and versions still exist in museums today. That wasn't the only confirmation. In 1852, Foucault invented the gyroscope, a spinning wheel that resists changes in orientation, and showed it could detect the Earth's rotation too. In the 20th century, laser gyroscopes became standard in navigation systems on airplanes and spacecraft. Then there's the Coriolis effect. Artillery officers noticed cannonballs veering off course, not because of wind, but because Earth's rotation deflected them. In the northern hemisphere, objects drift to the right. In the southern hemisphere, to the left. This same effect shapes massive weather systems, like hurricanes spiraling across the globe. These discoveries weren't just academic. They transformed navigation, warfare, aviation, and space travel. So why don't we feel this wild spin? The answer lies in physics, specifically inertia and frames of reference. The Earth rotates at a constant angular velocity, completing one full turn every 23 hours, 56 minutes, and 4 seconds. At the equator, that translates to about 1,040 miles per hour, decreasing as you move toward the poles. But constant speed means no acceleration, and humans only feel motion when acceleration occurs. Think about driving at 60 miles per hour on a smooth highway. You feel nothing until you brake or turn. We're moving with the Earth, not against it. The ground, oceans, and atmosphere are all rotating together. If Earth suddenly sped up or slowed down, we'd feel it instantly, and catastrophically. There's also centrifugal force, the outward push from rotation. At the equator, it slightly counteracts gravity, about 0.3% of gravitational pull. That's why you weigh just a bit less at the equator than at the poles. Over billions of years, this force caused Earth to bulge at the equator, making it wider than it is tall. But day to day, it's far too weak for us to notice. Gravity overwhelmingly keeps us grounded. The atmosphere rotates with us too, Otherwise, we'd experience constant 1,000-mile-per-hour winds ripping across the surface. Our inner ears play a role as well. They detect changes in motion, not steady movement. Since Earth's rotation is extremely slow, one rotation per day, it doesn't disturb the fluid in our balance organs. That's why spinning in a chair makes you dizzy, but living on a rotating planet doesn't. In the modern world, Earth's rotation shapes nearly everything. It creates the day-night cycle that governs our circadian rhythms, influencing sleep, mood, and hormone release. It drives global wind patterns, jet streams, and ocean currents that regulate climate. Satellites rely on Earth's spin, especially geostationary satellites that match its rotation to stay above one spot. Space agencies launch rockets near the equator to take advantage of the extra rotational speed. GPS systems constantly correct for Earth's rotation. Without those corrections, your location would drift by miles. Rotation even shapes society. Time zones exist because the planet spins. Cultures near the equator experience consistent daylight year-round, while polar regions endure months of darkness or sunlight. Climate change is subtly altering Earth's rotation too. Melting ice redistributes mass, slightly changing spin speed and length of day by milliseconds, enough to affect atomic clocks and global technology. Looking ahead, Earth's rotation will continue to change. Tidal friction from the moon is slowly slowing the planet down, lengthening days by about 1.7 milliseconds per century. In tens of millions of years, days will be noticeably longer. Life will adapt, just as it always has. Extreme events like asteroid impacts could theoretically alter rotation more dramatically, though such scenarios remain rare. Meanwhile, humans may recreate rotation in space habitats, using spinning structures to simulate gravity for long-term space travel. But maybe the deeper question isn't why we don't feel Earth spinning. Maybe it's why we assume stillness at all. We're also orbiting the sun at 67,000 miles per hour and moving through the galaxy at over 500,000 miles per hour. Motion is relative. Our senses evolved to focus on survival, not cosmic awareness. Perhaps feeling still is a gift, one that keeps us grounded in a universe that never stops moving. So there you have it. The Earth spins silently beneath our feet, a reminder that reality is far more dynamic than it feels. What part of this blew your mind the most? If this shifted your perspective, like and subscribe for more deep dives into science mysteries and hit the bell so you don't miss what's next. Thanks for watching. See you next time.